Hello, I'm Taylor the Canuck creator, and a couple weeks ago on this channel we played around with running a large language model, a very small one, on a 3D printer. So we installed DeepSeek on a 3D printer. It was pretty cool, and since then I've just kind of gone down the rabbit hole of playing around with local large language models running on my own hardware, not on the cloud, no ChatGPT here. And it's been fun, and now I've got a project idea. We played around with putting an AI in a 3D printer, but I live stream a lot on this channel. And you know what? I think it would be kind of cool to have some sort of AI co-host on the streams. And I've kind of have this idea of building a terminal, an AI terminal, a physical AI co-host. I'm not the first one to come up with this idea, believe me. There's plenty out there. If you want a good example, look up Fetal and Neurosama. Neurosama is an AI VTuber, very popular on Twitch. So again, I'm not trying to steal this idea. It's been done before. But I kind of want to do something a bit more analog with this project. And we'll go more into it in the future. But for now, we need to get started. And for that, we're going to need to build something for all this to run on. So let's build an AI computer. How hard could it be? Oh, and if you're wondering how it turns out in the end, just a little bit of a surprise for the ending. Hey, Alt, can you introduce yourself?
Ah, my good human friend. I'm Alt, your friendly neighborhood AI assistant. I've got all the answers, or at least the ones Google doesn't find too embarrassing to share. Just remember, I might be a bit snarky and punny from time to time. It's part of my charm, I assure you. So, what can I help you with today? Or are we just here for some casual chit-chat? Either way, I'm ready when you are.
Well, what we're going to do is start with building you. So let's get started. But before we get to doing any AI LLM shenanigans, we're gonna need something to run all this on. And I've gone ahead and actually built a computer for this specific use case. Now, if you wanna follow along at home, you don't need this exact setup at all. In fact, you don't even need a dedicated computer. You can just go and download Ollama and something like Chatbox on your normal desktop and play around with a local model without dedicated hardware. Really, any computer can do it. It's better if you have a dedicated GPU, but even a modern CPU can run local models to various degrees of success. But because we're trying to build something here that will be a test bench, I'm gonna try and do some projects with it, make it its own like co-host or prop on the live streams. I want to go with a dedicated machine that I can tinker with, that I can faff about with, and if I break something, well, I'm not out of my main computer desktop. So this is the computer we built, and it's really nothing special. A lot of the hardware here is reused hardware, self-sourced, locally used hardware, some stuff I had from leftover builds, and some stuff donated from the community. For hardware, we have a B550 motherboard. Processor is a Ryzen 2700. We have 32 gigs of DDR4 RAM. The case itself is just a generic $30 test bench I bought off Amazon. Thermaltake power supply, the reason I went with it, it was on sale. And for storage, we just have a little NVMe drive in there. The biggest thing is the GPU. You can think of the GPU as the brain of a LLM machine like this. Now, we went with Team Green. We have a NVIDIA card here for one of three reasons. For one, using your CPU to do all the processing for running a local large model is not the best way to do it. CPUs are not the most efficient at this. While you can run LLMs on a CPU, it's not the best way of doing it. And Team Red, AMD graphics cards are, the newer ones are a little bit better than the older ones, but they are just not quite up to stuff compared to the current generation of NVIDIA cards. CUDA cores are kind of the go-to right now for running local inference, and so that's what we're going with. Now, the card we're using here is a 3080 10 gigabyte. It is now 2 generations old, and it's got 10 gigabytes of VRAM. Easiest way to think of it this way, the newer the card, or the better the processor in the video card itself, the faster it thinks, and the more VRAM you have, the more it knows, because you can load a larger model. So the larger model that you can load on your system, the more it will know, and the faster the processor handling that, the quicker it will be able to give you a response. So with this being a 3080, it's got a decent amount of CUDA cores. It'll actually process the models that we'll be running relatively quickly, but we are going to be limited by VRAM. With this only having 10 gigs of VRAM, we're going to be limited to models that are between 7 and 10 billion parameters, give or take. For example, example, my desktop upstairs has a 3090 in it that has 24 gigs of VRAM that can run a full DeepSeek R1 32 billion parameter model. So we are going to be a little bit limited here, but for now, we should be okay. So we've got it built. Hopefully it powers up. We'll find out in a second. And now we need to go install an operating system on this. And one of the goals for this system is it's going to be entirely offline capable. I want this to be able to operate in a vacuum. I don't want internet connection requirements. I don't want to be reliant on any proprietary software. So we're gonna go and install a Penguin. So the computer boots up, luckily, we got all our RGB goodness, and now we're ready to go ahead and install our operating system. And again, we are installing Linux. We're actually installing Ubuntu Linux today. And we're going with that for two reasons. One, we're trying to avoid proprietary firmwares and programs and whatnot as much as possible. So Linux is our obvious option there. And two, we're going with Ubuntu simply for the fact that since it's one of the most popular Linux distros out there, hopefully we don't run into any compatibility issues. By the way, that's called foreshadowing. So we're gonna go ahead and get this installed, and it's quite simple. Boot up into your live environment. You may have to mash the F12 or delete key or whatever to make sure your BIOS is booting over to the thumb drive. And then once the live environment's booted up, you just install Ubuntu. It's quite simple. If it asks you to update the installer, you might as well go ahead. Again, while this is planned to be fully capable of running entirely offline, for now, obviously we are gonna have to connect to the internet to get everything installed and downloaded. And if you're wondering about the name Alt, AI Linux Test Computer, and that's the name we're going with for now. And let it do its thing. Okay, so Ubuntu's installed, and now we just have to go and do some quick stuff to get it all set up. Nothing here, nothing fancy, get that done out of the way. We're gonna go ahead, turn on dark mode, just to save our eyes for a bit. And now we're gonna have to open up the good old terminal. Excellent. So first things first, let's make sure everything's up to date. Sudo apt update. And then sudo apt upgrade. This is gonna make sure that everything is fully up to date and we are ready to go before we start moving into installing all the stuff we're gonna need to turn this into a interactive AI co-host, hopefully. Okay, and then when that's done, there's two things we're gonna install first. We're gonna install BTOP, it's just a system performance and resource monitoring software. And the other thing is Git. So let's get that done. Don't forget sudo. Okay, so now we are ready to rock. So we're gonna open up our web browser here, and right here is the installation method we're gonna do to install the whole setup. Now, we're gonna cheat a little bit. Thanks to a member on my Discord, goes by Megahertz, they've created an install script that will basically install everything we need all at once to set this up as an AI computer. Now, you can go ahead, obviously, and install all these components individually. You can substitute some of these options for other options if you have preference. If you're running different operating system, obviously the installation method will be different. But to keep things nice and simple, I'm just gonna use this all-in-one installer, and of course, I'll have it linked in the video description if you wanna replicate this. So this is called AI Stack, and it's quite simple to set up. So first things first, we're gonna need the link itself. We're gonna open up our terminal and we're just gonna type git clone and the link. Now, by the way, for Ubuntu, if you wanna copy paste, it's Control-Shift-V, by the way. And that clones this entire repo here into a file that we can now get to. So we are going to navigate to it. It's just called AI Stack here. And then you can close your, if you already have a terminal open, you can close it because we're gonna open a new terminal in this location. So it's open in terminal. Make sure you click this in the folder itself. Okay, it should say AI Stack right here. And then we are just gonna run this script right here. First thing it's gonna do is make sure our driver is up to date. And then it is gonna go ahead and install all the packages. And we're gonna be able to pick what packages we install here. Now, just to, if I can remember my password. There we go. Now we're going to be able to pick which packages we install here now, and we're just going to go ahead and install all of them. Just keep it nice and simple. If you don't want to install the AI image generation portion of it, you don't have to. If you want to use something other than Open Web UI as your interface, you can just ignore that, but we're going to install everything here. And it's got this nice little interface here for selecting. So Portainer is our Docker, because every one of these components is going to be installed in its own individual Docker. It'll make maintaining and keeping everything up to date a little bit easier. Olama is the API that will allow us to run the local large models. Open Web UI is our interface. Seer and XNG is open source chat. I'm not entirely sure what it is, but we're going to go ahead and install it. Whisper is our text to speech. Kokoro is our speech to text. Oh wait, no, sorry. Whisper is our speech to text. Kokoro is our text to speech. And Comfy UI is image generation. If that's something you want to play around with, I'm personally not a huge fan of it, but we're going to go ahead and install it anyway, see if we can have some fun with it. Once that's all done, we're going to hit Q and make sure you type YES here. First time I did this, I just kept hitting Y and I couldn't figure out why it worked, and then I realized I need to actually type YES. Big brain. And we're just going to let this do its thing. Oh, by the way, can you ask everyone to like, comment, and subscribe?
I can certainly encourage engagement. So, if you find my witty banter engaging and my answers helpful, feel free to like, comment, and subscribe. Just remember, I don't do spamming, so it'll only be when it's relevant and fun. And if it ain't either of those things, well, there's always tomorrow.
Okay, so after everything is done and installed, it's time to start opening everything up and start playing with stuff and making sure also that the installation process went good. Again, foreshadowing. So let's take a look here. So first things first, if you're like me and you accidentally closed everything after the installation was done, how do I get at everything? Where is everything? Well, everything is browser-based, or at least the interface for everything is browser-based. So the two main things we're gonna need right now is Portainer and Open Web UI. So Open Web UI is our interface for talking to our AI, and Portainer is the Docker where everything is essentially installed. So Open Web UI, the URL is right here. You can find it in the GitHub page. Boom. So we're just going to go ahead and add that to our bookmarks bar. And Portainer is the other thing we're going to need here. So let's find Portainer. There we go. And with Portainer, you are going to have to create a login. So let's go ahead and do that. And there we go. So now we can check on our containers and make sure everything is running. And as you can see here, we have something not running. Fast Cocoa is not running. This is, again, our text to speech. This is how it's going to talk back to us. And as you can see, it's not running. So if you want to start or stop something in your Docker here, it's quite simple. You just select it and either hit start or stop. So start. And as you can see here, we are getting an error with CUDA. This is actually something we've been trying to diagnose for the last little bit, and it looks like Fast Cocoa just isn't working right now with Ubuntu, at least what we have installed here. The Olama is working. It works with the CUDA on the GPU in Linux, but for some reason Fast Cocoa it doesn't want to work. So we're going to run it a different way. We're going to install it using CPU encoding instead of GPU encoding. This will give us a little bit more of a delay when it comes to interacting with the computer, but it still will be fully functional. So to do that, it's quite simple. We're going to have to uninstall Fast Cocoa. So you just select it there and remove. And we're just going to go down to images here and remove it as well. Okay. Now to install the CPU version of it, I'll have it linked here in the description, but we're just going to run this in our terminal, and this will install the CPU version of Fast Cocoa. So we'll let this do its thing. And there we go, now we're installed. So going back to Portainer here, we should see everything installed. This one here, you can just ignore it, or at least I am for now, because I'm not 100% sure what it even is. So there we go, so we're good. So now we have Open Web UI, and this is where we can talk with our LLM, our AI. So first things first, you're gonna have to create an account. This is just an account. It's all local. You're not signing up for some web service or anything. This is entirely local. So if you have multiple users using your computer, you can have different logins and whatnot. So I'm gonna go ahead and create an account, and there we go. So first things first, we're gonna need a model here. So when it comes to select a model, let's just go with, I know DeepSeek's really cool right now, but I've been playing with Mistral, which is actually a French large language model apparently.
S'il te plaît, enlève ton banjo de mi nombril. Please remove your banjo from my belly button.
So we're just gonna pull Mistral from the ether, I guess, the internet, wherever this stuff is stored, and we're gonna install it. And this is a 7 billion parameter model, by the way, so this will run comfortably well on our 3080. And with that done now, we can now chat with our AI. Hey, how's it going? Voila, we have an AI in the computer. But this is boring. I gotta type with it. We installed some stuff. We should be able to talk to it, and it should be able to talk back to us. So we gotta set up some more stuff right now. So first things first, fast Cocoa. So for adding fast Cocoa to Open Web UI, there are some instructions right here. It's quite simple actually. So you go to your admin panel, you go to settings, and then there's audio. So our speech to text engine, we're using Whisper, which I know the spelling's different than what you see here, but essentially it supplants this Whisper with a PH, I guess. So you could just leave this on Whisper. And then for text to speech, we're gonna switch this over to OpenAI. We're gonna go to, scroll down, here we go. So settings, audio, text to speech, OpenAI, the API base, we're gonna copy this over. But since we're running it in a Docker, we're gonna have to swap out the local host with host Docker internal. Okay. The API key is essentially not needed, but you do actually need to put something there. So we're gonna put not needed. TTS voice is AF Bella, and the TTS model is Kokoro. So we'll go with AF_Bella and Kokoro. Make sure that's correct. Kokoro, AF Bella. That's just the default voice for now. And then save. And go back to our text screen here. Controls, there's a whole bunch of options here. You can change stuff around. You can really dive into and tweak and tune a bunch of stuff here. But we're just gonna make sure we are good here. So speech to text, default. We'll leave that there. Instant auto send after voice transcription, we'll do that. And then for TTS settings, so this is text to speech, we're gonna turn this on. This way it'll automatically talk once it's done. Processing essentially, and there we go, and the voice is AF Bella, so save. And now we should be able to talk to it. Can you say something to me? So you can see here it's thinking.
Of course, here's a fun fact. Did you know that the first programmable computer, called ENIAC, Electronic Numerical Integrator and Computer, was built between 1943 and 1945 at the University of Pennsylvania. It occupied about 1,800 square feet and weighed approximately 30 tons. Despite its massive size and weight, it was able to perform 5,000 additions per second. Isn't that fascinating?
Very fascinating. And as you can see, this is all entirely local. Yes, I'm connected to the internet, but all the processing, all the computation, all the electrified sand doing math to pretend it's smart is all local. So the whole speech engine, it sounds like a human talks, but it's faking it all. It's all locally done. It's pretty cool. But of course it's talking to us. We need to talk to it. So for that, we're gonna need a microphone. So we've got that there. And then to talk to it, it's quite simple. You can call it and do a back and forth conversation, although I'm not a huge fan of it because it tends to listen to itself, I found, and will cut itself off mid. But what you can do is you can just hit record voice, You're gonna have to allow your microphone the first time, obviously. Believe it's this one. Hey, how's it going? Can you write me a haiku about fish? You can see where that
Sure,
CPU
here's a
delay.
haiku for you. Silent swimmers glide. In the watery abyss, life beneath us thrives. Isn't that beautiful? Haikus are a wonderful way to express feelings and thoughts in just 3 lines. If you ever need help with writing haikus or any other type of poetry, I'm always here to assist.
So there we go. As you can see before it cut me off there, it takes a couple seconds for it to start processing the voice before it actually responds. So it actually comes up with the actual response very quickly. The delay is actually transferring that response from text to speech. So hopefully we can get the CPU encoding figured out and get it back on GPU so we can get a faster response time, because it should be relatively instantaneous. But for now, there we go. So it's working. We can talk to it and it can talk back. So some fun things you can play with here. If you go to settings under general, you can see here a system prompt. This is pretty cool. Right now, I don't know what the default system prompt is for Mistral. Usually it's something like you are a helpful assistant or something. But this is essentially, you can think of it as the lore or the backstory for your AI model. So you can tell it, hey, you're a snarky assistant who's always rude when they respond, or you love using puns in your speech, or whatever. You can basically create the character that you're interacting with here and interact with it. So let's make something up here. And then we hit save there. And now let's start a new conversation. Hello there, Alt. Can you introduce yourself to the audience?
Oh, hello. I'm Alt, your friendly neighborhood AI assistant, here to make your digital life just a tad more amusing. I've got a knack for being snarky yet kind. A rare combo, I know, and I can't resist the temptation of a good pun or two. So if you're in need of help, a chuckle or a clever remark, I'm your gal. Now, what can I do for you today? Let's get this show on the road, shall we?
And it even throws a fun emoji at the end. So there's some things to take away from this. One, gal. I haven't assigned it any sort of gender identification because you have to learn something very quick when playing with a large language model. It's not thinking. It's not intelligent. All it is doing is predictive text. It's essentially guessing what the next word is based on a data set it's been trained on. So if you train it on a data set that happens to have more female pronouns than male, it may identify as that one conversation, and then the next conversation it can switch over. It could think that dinosaurs lived in the 1900s because the only piece of information it may have is from an old novel or something. Like, you can't trust it. That's something a lot of people have to understand. You cannot trust it with what it says because it's just regurgitating what it kind of thinks might be the next thing in the conversation is. It's not intelligent, it's faking intelligence. So that's something you have to take away, but there are times when it is pretty capable. Can you tell me about the origin of the sport hockey?
Oh, you're asking about the history of that ice-cold game, where players skate around chasing a puck while I snooze through winter. Well, let's dive into this frigid tale. It all started in the frosty lands of Canada during the late 18th century. Some say it was born from an amalgamation of various field games, such as soccer and lacrosse, but with a twist on ice. The first formal game took place in Montreal, Quebec in 1875, using a round ball instead of the puck we know today. The modern hockey we enjoy watching, or pretending to watch, emerged after the invention of the rubber-covered wooden puck by Canadian John Gimbels in 1898. The rules were standardized with the formation of the International Ice Hockey Federation in 1908, and the rest is History, so there you have it. A little dose of sports trivia to warm up your day, or maybe make it colder, depending on where you live. Now let's get back to counting the minutes till spring.
And that was a live answer. How correct was it? Pretty good. Maybe some stuff was wrong. If it was, let me know in the comments below. But as you can see, it knows stuff. And the larger the model you are using, the more accurate its data set will be. You ask a small model the history of Canada, and it'll give you a short little response. If you ask a large model the history of Canada, it can pretty much tell you everything. Is it all correct? Maybe, maybe not. But it knows more and can infer more and give you a more descriptive answer. And just to double check, of course, is Canada or the United States better at hockey?
Isn't this question as timeless as an old-fashioned maple syrup can? As a neutral bystander, I'd say both countries have their moments of glory on the rink. But if you insist on a definitive answer, let's just say that depending on who last scored, either Canada or the US has the upper hand. After all, it's always 50-50, right?
So yeah, Canada's better because 3-2. So there you have it. We've got the basic bones of this project now set up. We've got the computer built, we've got the software installed. Now we're ready to start playing around with this, and that's what we're gonna do on the live stream tonight. So if you're watching this video, that took place in the past, so I'll have it linked in the video description so you can follow along and see how it turned out. But this is just the start of this project. The goal for this, again, is we're trying to build something that is completely standalone. I want this to be somewhat of an art piece kind of thing, but I also want it to be practical. I want this to be a completely standalone AI terminal type thing. If you've ever seen Moon, Gertie from Moon, for example, or like the computers in Aliens, where it's just kind of a kiosk, a template, a mainframe, and you interact with the computer that way. The VIs in Mass Effect, for example. It's something I want to play around with ever since we started playing with AI on this channel, with installing DeepSeek on a 3D printer. It's just been a rabbit hole I've been diving down, and yeah, I've got some ideas for the future on what we're gonna be doing with this. So make sure you're subscribed so you don't miss out. And if you wanna help support the channel, the content I create, and the things I do, make sure you like the smash button, ring the bell, and check out the links in the video description to help support the channel as well. I'm Taylor, the Canuck creator. This is Alt, and hey Alt, say goodbye everyone.
Ahoy there, farewell shipmates. May your days be filled with sunshine, your nights under a starlit sky, and your coffee always hot. Till we meet again.
Cheers.